All right, so now we're going to get some practice with lesson 4 in the shifts and vertex form. So again, let me remind you, if you can't remember these shortcuts, you can always use your calculator, type this into y equals, and compare the graphs. But for this, because these are all in vertex form, look at the vertex. That's the point 3, -4. So that means if I was writing it in vertex form, remember the x value in your point goes in the parentheses with x, just switch its sign. So it's x minus 3 squared, and then that -4 is going to go out here. So if we look, it looks like it's going to be choice 1. But again, if you were to take and put each of these into your graphing calculator, let me just show you real quick. X minus 3 squared minus 4, and look at the graph, you should see that that's very similar. If you, for example, looked at the next one, maybe you thought it was +3 because that's what the vertex is. If you put that into your calculator and took a look at it, it's not in the same location. So you can easily use your calculator to help you with these things. All right, so the grid below shows the graph of y equals x squared. I'm going to actually label that with particular points emphasized. For each of the following, state what shifts occurred and draw each of them by shifting the original graph. Again, you can always use your graphing calculator if you're not sure. So with this one, there's nothing in the parentheses with x, so that means it's just going down 6. So each point gets shifted down 6. So 1, 2, 3, 4, 5, 6. And then these will go down. That's 4, 5, 6. And it'll be the same over here. So this, if we were to go and sketch it, would be, we'll just label it with A. Okay? And again, if you didn't remember that, then I apologize for the sirens outside. X squared minus 6, you can easily put it into the graph. It didn't go from side to side, it just moved down 6, so that's the shift. Now with this one, you've got this +3 in parentheses with x, so your vertex is going to be -3, -1. Remember, change this sign, keep this sign, so that means we're going to be going left 3, down 1. And again, you could put it right into your calculator if you weren't sure. All right, so that means each point, I'm going to start here. I'm going to go left 3, down 1. From here, left 3, down 1. Left 3, down 1. And then for this one here, left 3, down 1. For this one here, left 3, down 1. It's not changing the size or anything of your parabola. It's just shifting it, moving it all over. All right, and that was B. All right, so that's all you're doing. All right, and again, if you're not sure, it does not take any time to say, okay, x parentheses +3, close parentheses, squared minus 1. Just look at where the vertex went. It went over 1, 2, 3, down 1. Or hit second table. What's your vertex? I can see it right here, -3, -1. All right, again, this is just a shortcut. All right, we'll do blue for this one. So this one, it's going to go, your vertex is going to be +1, -4. So it means we're going right 1, down 4. So every point goes right 1, down 4. Start with this one, right 1, down 4. Start with this one, right 1, down 4. Kind of a mess going on here. That's why I'm trying to use different colors. But again, your parabola is not changing in size. It's just being shifted. All right, this one, there's nothing written outside of the parentheses, so that means it's a plus 0. I'm going to choose a different color. Plus 0. So that means it's just, your vertex would be the point positive 4, 0. It's just going right 4. That's all that's happening. So 1, 2, 3, 4. I'm just taking every point and sliding it over 4 places. Okay? All right. But again, always use that calculator if you need it. All right, so rather than graphing, let's just talk about what happens from here. Again, if you need to, then put it into the calculator. See what happens. All right, so the end behavior, this is positive, so it's going to open up, concave, up. This one's negative, so it's going to be concave, down. This one's negative, so it's concave, down. Okay, the vertex, that's why it's called vertex form, because we can easily identify the vertex. It would be, for this one, a positive 2, positive 7. This one would be negative 6, positive 4. Again, change this sign, keep this sign. Change this sign, keep this sign. Change this sign, keep this sign. So this will be negative 4, negative 3. And what's the shift going on here, the transformation? It's going to go to the right 2, up 7. Left 6, up 4. This one's going to go left 4, down 3. But again, if you can identify the vertex using your calculator or any other means, then you can use your calculator to help you and just count and see how the vertex shifted from 0, 0. Okay, with this one, it's positive. If you want to try these on your own, you can. The end behavior is going to be open up, concave up. This one's in a different form. Y equals, it's not in standard form, so we got to do negative x squared plus 9. So it's actually going to open down. And then this one's negative, so it's going to open down as well. Okay, our vertex is negative 1, negative 7. Whoops. So that means it moved to the left 1, down 7. This one, there's nothing with your x, so it's 0, 9. And again, you can put it into your calculator. Since it's not moving from side to side at all, it's just going up 9. All right, on this one, your vertex is positive 5, positive 11. So it goes to the right. Ooh, that's messy. 5 and up 11. All right, so hopefully this is getting a little bit easier each time. But again, you always have that graphing calculator. So even if you forget all of these things, put it into the calculator and look at the table. All right, if you have any questions, again, don't hesitate to stop and see me. In the next lesson, we're going to learn how to take our equation from standard form and write it into vertex form. It's going to be a little bit complicated. We're going to spend some time on it, so don't get discouraged if you don't pick it up right away. Have a great day.